Welcome to HVAC Official Channel. Chapter 1. Introduction to HVAC, Heating, Ventilation, and Air Conditioning. HVAC stands for Heating, Ventilation, and Air Conditioning. It is a system used to provide thermal comfort and acceptable indoor air quality in residential, commercial, and industrial buildings. Heating, used during winter to keep the environment warm. Common heating systems include furnaces, boilers, and heat pumps. Ventilation, the process of exchanging or replacing air within a space. It removes moisture, odors, smoke, heat, and airborne bacteria. Air conditioning, used to cool down a space. It removes heat and humidity to maintain a comfortable temperature. Chapter 2. Types of HVAC systems. 1. Split air conditioner contains an indoor unit, evaporator coil and blower, and outdoor unit, compressor and condenser. Commonly used in homes and small offices, energy efficient and easy to install. 2. Window air conditioner, a single unit fitted in a window opening. Compact but less efficient than split AC. Ideal for small rooms. 3. Central air conditioning system. Cool air is distributed through ducts, used in large buildings or homes, expensive but effective for large spaces. 4. VRF/VRV system. Variable refrigerant flow. Advanced technology. Multiple indoor units connected to one outdoor unit. Used in hotels, malls, and corporate buildings. Energy efficient, customizable and quiet. 5. Chiller systems, used for cooling large spaces like airports, hospitals, and factories. Works by circulating chilled water to air handling units. 2 main types: air-cooled chiller, water-cooled chiller. Chapter 3. Refrigeration Cycle. How AC works. Detailed explanation. The refrigeration cycle is the heart of air conditioning. It is the process that allows your AC to remove heat from inside a room and release it outside, making the room cooler. It works on the principle of heat transfer and phase change of refrigerant, gas to liquid and back. Main components of the refrigeration cycle. Let's break it down step by step. 1. Compressor, the heart of the system, located in the outdoor unit. Function: compresses the refrigerant gas, low-pressure cool gas, into a high-pressure, high-temperature gas. It's like a pump. It moves refrigerant through the whole system. This compressed gas is then sent to the condenser. Example, like when you compress air in a pump. It becomes hot. Same happens with refrigerant. 2. Condenser coil, heat remover. Also in the outdoor unit. Function: this is where the hot, high-pressure refrigerant gas releases its heat to the outside air. As it loses heat, the gas condenses into a liquid. A fan blows outdoor air over the condenser coil to speed up this cooling. Real-world tip. That's why outdoor AC units feel hot. They're releasing indoor heat outside. 3. Expansion valve, pressure dropper. This is a small nozzle, or a valve between the condenser and evaporator. Function: it reduces the pressure of the liquid refrigerant. As the pressure drops, the refrigerant becomes cold, ready to absorb heat. There are different types: capillary tube, thermostatic expansion valve, TXV, and electronic expansion valve, EEV. Evaporator coil. Cooling magic happens here. Located in the indoor unit, the cold, low-pressure refrigerant flows into the evaporator coil. A blower fan blows warm room air over this coil. The refrigerant absorbs the heat from the air, turning back into a gas. Result: the cool air is blown back into the room, and the refrigerant gas returns to the compressor. And the cycle starts again. Cycle repeat. Compressor, condenser, expansion valve, evaporator, back to compressor. This cycle continues until the desired temperature is reached. Role of refrigerant, gas. Refrigerant is the special fluid that changes from gas to liquid and back to gas. Common types: R22, R410A, R32. R22 is being phased out because it's harmful to the environment. Simple example. Imagine it like this. Compressor equals heart pumping blood. Refrigerant, condenser, equals releasing body heat, sweat. Expansion valve equals narrowing veins, lowering pressure. Evaporator equals cooling skin, absorbing heat. Important safety tip: never touch AC pipes during operation. One is very hot, high-pressure gas. The other is very cold, evaporator line. If refrigerant leaks, it can affect health and system efficiency. Quick recap. The refrigeration cycle has 4 parts: compressor, condenser, expansion valve, and evaporator. It works like magic to take away the heat from your room and release it outside, keeping you cool and comfortable. Chapter 4. Split AC. Components, installation, and maintenance. Full explanation. What is a split AC? A split air conditioner is one of the most common air conditioning systems used in homes, offices, and small shops. It is called split because it has 2 main units, an indoor unit and an outdoor unit, which are installed separately. It is known for quiet operation, energy efficiency, better cooling performance, easy maintenance. Part 1. Components of a split AC system. Let's understand each part in detail. 1. Indoor unit, installed inside the room. Main parts inside the indoor unit. Evaporator coil, cooling coil, absorbs heat from the room air using cold refrigerant. It cools the air. Blower fan, circulates air over the cooling coil and blows cold air into the room. Air filter, captures dust and small particles to keep the air clean. Swing motor and flap, louver, moves air up, down, or side to side for better air distribution. Drain pipe, removes moisture, water, collected during cooling. Electronic display and remote sensor, shows temperature, mode, and receives signals from the remote. 2. Outdoor unit, installed outside the building, rooftop, balcony, or wall bracket. Main parts inside the outdoor unit. Compressor, compresses the refrigerant gas and pumps it through the system. It is the heart of the AC. Condenser coil, releases heat absorbed from the room to the outside air. Fan, motor, and blade, blows air over the condenser coil to help remove heat. Capacitor and control board, helps in starting the motor and controlling the system. 3. Connecting parts between indoor and outdoor units. Copper refrigerant pipes, 2 pipes. One for high-pressure gas, discharge. One for low-pressure liquid, suction. Electrical cable, transfers power and control signals between units. Insulation foam, covers copper pipes to prevent heat loss and condensation. Wall sleeve, hole cover, used to safely pass pipes and wires through the wall. Part 2. Installation process of a split AC step by step. A professional installation is essential for proper cooling and safety. Step 1. Select the right location. Indoor unit should be installed at a height of 7 to 8 feet. Ensure there is no direct sunlight or heat source. Outdoor unit must be in well-ventilated, shaded and dust-free area. Step 2. Fix the indoor unit. Attach the mounting plate to the wall with proper alignment. Drill a hole about 3 inch through the wall for passing pipes and wires. Mount the indoor unit on the plate carefully. Step 3. Install the outdoor unit. Place it on a concrete base or wall bracket. Ensure anti-vibration pads are placed under the unit. There should be at least 12 inches gap around the unit for airflow. Step 4. Connect copper pipes and wires. Measure the correct pipe length. Use flare nuts to connect the refrigerant pipes. Make sure wiring connections are correct, usually 3-core cable. Insulate the pipes with foam and tie them neatly. Step 5. Vacuum and refrigerant charging. Use a vacuum pump to remove air and moisture from the system. If refrigerant level is low, fill it as per the system requirement. Never skip this step. It prevents gas blockage and improves efficiency. Step 6. Final check and power on. Check all pipe joints for leaks. Switch on the AC and test all functions. Cooling, swing, modes, remote. Check if drain water is coming out properly. Part 3. Maintenance of a split AC. Regular maintenance increases life and efficiency. 1. Clean the air filter. Remove and clean every 2 to 4 weeks. Wash with water and dry before placing back. 2. Clean the indoor coil. Dust or fungus can block cooling. Clean with a soft brush or vacuum. 3. Check gas pressure. If cooling is low, get gas pressure checked by a technician. 4. Clean the drain pipe. Prevent water leakage or foul smell. Clean once every 3 months. 5. Outdoor unit cleaning. Blow air to remove dirt and leaves from the coil and fan. 6. Professional servicing. Get full system serviced every 6 to 12 months by a qualified technician. Pro tips. Don't install indoor unit directly over your bed. Use stabilizer if voltage fluctuation is common. Avoid running AC with open doors or windows. Use sleep mode at night to save electricity. Line for this chapter. Split AC is one of the most efficient and reliable air conditioning systems. If installed and maintained properly, it can last over 10 years while giving you the best cooling comfort. Chapter 5. Window AC. Structure, installation, and repair. Full guide. What is a window air conditioner? A window AC is a compact, self-contained air conditioning unit that is designed to be installed in a window frame or a specially made wall opening. It is a popular cooling system for small rooms, apartments, and single offices. Part 1. Structure of a window AC. Unlike a split AC, which has 2 separate units, a window AC includes all components in one box. Let's break down its main sections. 1. Compressor. Located in the rear part. Compresses the refrigerant and sends it to the condenser, main component that powers the cooling cycle. 2. Condenser coil, also in the back, outside portion, releases the heat absorbed from the room to the outside air. 3. Evaporator coil, located in the front, facing the room, absorbs heat from the indoor air using cold refrigerant. 4. Blower fan and motor. A single motor runs 2 fan blades. One blows indoor air over the evaporator coil, cooling the room. One blows outdoor air over the condenser coil, removing heat. 5. Air filter. Removable filter in front of the evaporator. Traps dust and keeps air clean. 6. control panel and thermostat. Allows user to control temperature, fan speed and mode, cool, fan only, etc. 7. Drainage tray and pipe. Collects condensed water and drains it outside the unit. Part 2. Installation of a window AC. Step-by-step guide. Proper installation is very important for safety, cooling performance, and long life. Step 1. Choose the right location. Select a window that is not exposed to direct sunlight. Must have a proper power supply outlet nearby. The wall/window must be strong enough to hold the AC weight. Step 2. Prepare the window opening. Measure the AC dimensions carefully. Use metal brackets or wooden frame to support the unit. Some AC come with side panels to seal gaps in the window. Step 3. Mount the AC unit. Carefully lift and slide the unit into the opening. Make sure the rear of the AC slopes slightly downward, about 1/2 inch, for water drainage. Secure the unit using screws, brackets, or clips. Note: always use 2 people to lift and place the AC. It's heavy. Step 4. Seal the gaps. Use foam insulation strips or sealant to close all gaps between the AC and the window frame. This prevents hot air, dust, and insects from entering. Step 5. Connect the power plug. The AC into a grounded socket. Some units may require a dedicated circuit or voltage stabilizer. Step 6. Test the operation. Turn on the AC and test all modes. Check the airflow, temperature, swing, and drainage. Part 3. Common problems and repair tips. Problem 1. AC not cooling properly. Possible reasons: dirty air filter, blocked evaporator or condenser coil, low refrigerant gas. Solution: clean filter and coils. If cooling is still weak, call technician for gas refill. Problem 2. Water leaking inside the room. Cause: unit not tilted properly or drain hole blocked. Solution: tilt the rear lower, unblock the drain outlet. Problem 3. Unusual noise. Cause: loose fan motor, vibration or dust. Solution: tighten screws. Clean fan motor and blades. Use anti-vibration pads. Problem 4. AC not turning on. Cause: power supply issue, faulty thermostat or capacitor. Solution: check plug and breaker. Replace faulty parts if needed. Problem 5. Foul smell from AC. Cause: mold or bacteria on coils. Solution: clean evaporator coil with disinfectant. Wash air filter regularly. Part 4. Maintenance tips for window AC. Clean air filter every 2 weeks. Vacuum and wash the coils monthly. Check drainage line regularly. Cover the unit during off-season. Don't block airflow with curtains or furniture. Use a voltage stabilizer in low-voltage areas. Advantages of window AC. Low cost. Easy to install. Portable from one room to another. Great for small spaces. Disadvantages: noisy compared to split AC. Blocks window light. Less energy efficient. Limited to small room sizes. Quick recap for viewers. Window AC is a powerful and compact cooling solution for small spaces. With proper installation and regular cleaning, it can give you long-lasting comfort and great performance on a budget. Chapter 6. Chiller System. Types, working, and applications. Air-cooled chiller. Uses air to remove heat installed outside buildings. Easier to maintain but less efficient. Water-cooled chiller. Uses water and cooling towers. Higher efficiency. Requires regular maintenance. Working. Compressor compresses refrigerant. Condenser removes heat. Expansion valve reduces pressure. Evaporator chills water. Chilled water circulates in air handling units. Applications: airports, hospitals, industrial plants, shopping malls. Chapter 7. HVAC Tools and Safety Equipment. Full Guide Introduction. In the HVAC field, having the right tools and using them correctly is the difference between a successful and a risky job. Whether you're installing an AC, charging refrigerant, or repairing a chiller, tools and safety gear are your best friends. Let's explore the essential HVAC tools, their functions, and why they matter. Part 1. Essential HVAC tools and their uses. 1. Digital clamp meter multimeter. Purpose: checks voltage, current, resistance, and continuity. Use: test power supply in AC. Detect faulty capacitors or thermostats. Safety check before servicing electrical parts. Pro tip: always test voltage before touching wires. Safety first. 2. Manifold gauge set. Purpose: measures refrigerant pressure during charging or recovery. Use: has 2 gauges. High pressure, red. Low pressure, blue. Connects to AC for checking system pressure. Helps in refrigerant charging or recovery. Pro tip: must match the refrigerant type R22, R410A, etc. 3. Vacuum pump. Purpose: removes air and moisture from the AC system before gas charging. Use: connect after installation. Runs for 15 to 30 minutes to create a vacuum. Ensures no moisture or air remains. Why important? Moisture inside the pipe can damage the compressor. 4. Refrigerant recovery machine. Purpose: recovers refrigerant gas from the AC safely. Use: needed during repairs or gas transfer. Prevents refrigerant release into the environment. Tip: use a recovery cylinder for storage. 5. Leak detector. Purpose: finds refrigerant gas leaks. Use: comes in digital or soap bubble form. Point it near suspected leak. Alarm will beep or bubbles will form. Why important? Leakages cause poor cooling, compressor damage, and are harmful to the environment. 6. Refrigerant charging scale. Purpose: measures exact amount of refrigerant added. Use: place gas cylinder on scale. Monitor weight while charging. Avoids overcharging or undercharging. Accuracy equals better performance plus long life. 7. Pipe cutter. Purpose: cuts copper pipes cleanly. Use: rotate around the pipe to cut it neatly. Prevents pipe crushing or leakage. 8. Flaring tool. Purpose: makes flare, cone shape, on copper pipe ends. Use: helps connect pipes with flare nuts. Ensures tight seal between units. Tip: always apply flare oil for smooth finish. 9. Brazing torch. Gas welding kit. Purpose: joins copper pipes using flame and filler rod. Use: used in chiller piping or custom AC jobs. Requires gas cylinder, LPG, oxygen mix. Dangerous if misused. Must wear full safety gear. 10. Tube bender. Purpose: bends copper pipes without kinking them. Use: needed for sharp corners or tight spaces. Maintains smooth flow inside the pipe. Bending by hand can damage the pipe. Avoid it. 11. Allen key, hex key set. Purpose: tightens or opens screws in indoor and outdoor units. Use: compressor terminal, fan motor, and electrical boxes often use hex bolts. Always carry a full-size set. 12. Cordless drill machine. Purpose: makes holes in walls for mounting brackets and pipes. Use drill through brick, wood, or concrete. Saves time during installation. Must have multiple drill bit sizes. Part 2. Safety equipment. Always wear these. 1. Safety gloves. Protect hands from sharp metal, refrigerant burns, and electric shock. 2. Safety glasses. Shield your eyes during brazing, drilling, or refrigerant gas work. 3. Safety shoes. Prevent injury from dropped tools or electric contact. 4. Helmet. Especially on rooftops, buildings, or heavy chiller sites. 5. Voltage tester. Pen. Detects live wires before touching. Prevents electric shock. 6. Mask/respirator protects from refrigerant gas or dust during cleaning and servicing. Without the right tools and safety equipment, an HVAC technician is incomplete. Invest in quality gear, learn to use it correctly, and always put safety first. That's how professionals work. Chapter 8. How to install a split AC. Step-by-step installation guide. Introduction. Installing a split AC is a skilled job. A small mistake can affect the cooling, increase the electricity bill, or even damage the system. In this chapter, we will go through each step of installation in detail, including tools, safety measurements, and pro tips. Part 1. Tools required for installation. Before starting, make sure you have drill machine with bits, spirit level, measuring tape, wall bracket for outdoor unit, pipe cutter, flaring tool, vacuum pump, manifold gauge set, copper pipes, suction and discharge, electrical cable, 3-core or 4-core, drain pipe, insulation tape, and foam, clamp meter/voltage tester, ladder and basic hand tools. Part 2. Unboxing and inspection. Open the split AC boxes carefully. Check indoor and outdoor units for any damage or dents. Confirm accessories like remote mounting plate, user manual, drain pipe, screws, and wall plug. Part 3. Indoor unit installation. Step 1. Choose the best location. Wall should be strong, flat, and dust-free. Minimum 7 to 8 feet height from the floor. Leave 6 to 12 inches of space on both sides and top. AC should not face direct sunlight or cooking heat. Step 2. Fix the mounting plate. Hold the indoor unit's metal bracket against the wall. Use a spirit level to make sure it's straight. Mark holes with pencil, then drill. Insert wall plugs and fix the plate with screws. Step 3. Drill hole for piping. Drill a 3-inch hole in the wall behind the unit for copper pipes, suction plus discharge, drain pipe, power cable. Hole should be sloped slightly downward 5 to 10 degrees to drain water outside. Step 4. Connect the pipes and wires. Attach copper pipes to the unit using flare nuts. Connect drain pipe on the left or right, as per outlet. Connect electric wires as per color code or diagram in manual. Wrap all pipes, cables, and drain together with insulation tape neatly. Step 5. Mount the indoor unit. Hang the unit carefully on the mounting plate. Make sure it locks properly into place. Push the pipe bundle through the drilled hole to the outside. Part 4. Outdoor unit installation. Step 6. Select proper place for outdoor unit. Must be ventilated, shaded, and on firm surface. Avoid dusty areas or blocked corners. Leave 12 inches space around for airflow. Place unit on anti-vibration pads. Step 7. Mount or place outdoor unit. Fix it on ground base, wall bracket, or balcony. Use nuts and bolts to secure it tightly. Make sure unit is level, not tilted forward or backward. Step 8. Connect copper pipes and wires. Attach suction and discharge lines to outdoor unit using flare nuts. Use spanners to tighten, not over-tight. Connect power control cable as per diagram. Wrap pipes and wires with insulation foam. Part 5. Final steps. Vacuum, gas, and testing. Step 9. Leak test. Use manifold gauge to test for gas pressure leaks. Apply soap solution on joints. If bubbles appear, there's a leak. Tighten or fix accordingly. Step 10. Vacuum the system. Connect vacuum pump to service port. Run the pump for 15 to 30 minutes until pressure drops to -700 millimeters mercury. This removes air and moisture. Step 11. Open refrigerant valves. Open both suction and discharge valves using Allen key. System is now pressurized with refrigerant, factory charged. No need to fill gas unless pipe length is very long. Step 12. Power on and test. Switch on the MCB/power plug. Start the AC using remote. Check. Cooling air, swing function display. Water drainage outside. Compressor on-off sound. Bonus tips. Pipe length should not exceed 15-20 feet, ideally. Never bend copper pipes sharply. Use pipe bender. Drain pipe must have downward slope for proper water flow. If voltage fluctuation is common, use a stabilizer. Use weather shield for outdoor unit if exposed to rain. A professional split AC installation ensures better cooling, longer life, and energy savings. Always follow safety, accuracy, and proper tools, and your AC will thank you with perfect performance. Chapter 9. Types of chillers. Air-cooled versus water-cooled with working. What is a chiller? A chiller is a special HVAC machine that removes heat from water and sends that chilled water to cool large buildings, factories, or processes. It's mostly used in commercial buildings, data centers, hospitals, industrial plants. A chiller is the heart of centralized air conditioning systems. Part 1. Types of chillers. There are many types of chillers, but the two main types based on how they reject heat are 1. Air-cooled chiller. 2. Water-cooled chiller. Let's understand both in detail. Air-cooled chiller definition. An air-cooled chiller uses air to remove heat from the system. It has fans that blow outside air across condenser coils to release heat. Working process. Chiller uses refrigerant to absorb heat from water, just like a normal AC. The refrigerant carries the heat to the condenser coil. Large fans blow air over the condenser coil. This outside air removes heat from the refrigerant. Cooled refrigerant goes back to chill water again. Where it's used: small to medium-sized buildings, rooftop installations, where water is not available or expensive. Advantages: no cooling tower needed. Easy to install. Lower maintenance cost. Good for dry or desert areas. Disadvantages: less efficient in hot climates. Louder due to fan noise. Takes more space. Water-cooled chiller. Definition: a water-cooled chiller uses water from a cooling tower to remove heat from the system. It is usually installed indoors. Working process: refrigerant removes heat from chilled water. The heat is passed into a condenser. Instead of fans, cold water from a cooling tower flows through the condenser. This water absorbs the heat and carries it back to the cooling tower. In the cooling tower, the water releases heat to the air and comes back cooled. Where it's used: large commercial buildings, hospitals and malls, industrial cooling. Data centers. Advantages: more energy efficient, silent operation, better cooling in hot climates, takes less space indoors. Disadvantages: expensive installation, needs cooling tower and pumps, more maintenance required, needs large water supply. Basic chiller cycle, same for both types. Evaporator, chilled water absorbs heat from building. Compressor, compresses refrigerant. Condenser, rejects heat, air or water-based. Expansion valve, reduces refrigerant pressure and cools it again. Fun fact: one industrial chiller can cool more than 100 AC units worth of load using just chilled water. Conclusion: chillers are the backbone of central HVAC systems. Choosing between air-cooled and water-cooled depends on building size, budget, climate, and water availability. Understanding both helps you design and manage efficient cooling systems for any project. Chapter 10: Career in HVAC, Jobs and Scope. You can become HVAC technician, AC installer, chiller operator, AC mechanic, HVAC supervisor. Salary range: starting, local, PKR 25,000 to 60,000. Gulf countries, SAR 1,800 to 3,000 or more. USA, Canada, $18 to $40 per hour. Thank you for watching this complete HVAC course. I hope you've learned everything about air conditioning systems, chiller units, installation, maintenance, and career options. Now forget to subscribe for more technical and informative content. Until next time, stay cool and keep learning.